All right, here we are with balancing redox reactions. Step number one, go through and assign oxidation numbers. Oxygen's always -2, except for in hydrogen peroxide, which makes this chromium be +6 because it's got to add up to -2. Iodine's -1, chromium's +3. Over here, oxygen would be -2, which makes iodine be +5. Take your highlighter then. Highlight the chromium because it goes from +6 to +3. Does that go down in charge or up in charge? Down in charge, which means it's reduced, and then the iodine goes from -1 to +5, so that goes up in charge, and so that's oxidized. So let's write our oxidized half reaction down here below. That would be iodine, and then be careful of your formatting. Make sure that you put the arrow way in the middle and you leave lots of space. IO3 -1. Skip a few lines, and then let's put the reduction half reaction down below here. Cr2O7 2-. Leave lots of space, arrow, and then put the Cr +3, leave lots of space there as well. Step number 2, balance everything except for hydrogen and oxygen. The only thing that needs balancing besides hydrogen and oxygen is the chromium. Step number 3, balance the oxygens with water. 3 oxygens here, so I'll need 3 waters over here to balance the oxygens. 7 oxygens here, so I'll need 7 HOHs over here to balance the 7 oxygens here and here. Balance the hydrogens with H+, so I think I need 6 H+ here to balance with the 6 H's here. 14, so I think I need 14 H+ here to balance with the 14 hydrogens here. Lastly, use the electrons to balance the charge. So the charge on this side is +5. Charge on this side is -1. So I think I need 6 electrons here to get this side of the reaction to be -1 and balance with that side. Down here, I've got a +12 and a +6. So I think I need 6 electrons on this side to balance that. Take your highlighter right now. Highlight the 6 electrons here and the 6 electrons here, because one of the questions that's asked on several of the quizzes in the test is how many moles of electrons are transferred in the reaction. You can see 6 leave the left side and 6 end up on the right side. So 6 moles of electrons are transferred. Since they happen to match, you don't need to do this multiply the electrons so they're equal step. And now you can add the 2 half reactions together and cancel anything that's the same on both sides. So I end up with 3 HOH plus an I- plus 14 H pluses plus Cr2O7 2-, arrow, the electrons will cancel with one another. 6 H plus IO3- plus 7 HOH plus 2 Cr +3. I'm going to get some waters to cancel, and I think I get rid of these H+, and I end up with 8 H+. Did I do that math right? Let's check the charge. I've got 8, +5 total on this side, and then over here I've got +6 and a -1, so +5 right here. Chromiums match, hydrogens match, oxygens, 3 plus 4 is 7, and there's 7 there, and I think that's balanced. That's letter A. All right, let's follow the same steps for number 25, letter E. This one happens to occur in basic solution, so we need to do an extra step at the end. This one is MnO4- plus bromine -1, and then we end up with MnO2 on the right hand side and some BrO3, some bro over here on the right hand side as well. Watch your pluses and minuses. Be really careful and picky about how you write. Use lots of space on paper. Assign oxidation numbers. Oxygen -2. Bromine -1, oxygen -2, manganese over here is easy to figure out. This oxygen's -2, which means bromine here must be +5. This one's tough. What must that manganese be? positive 7. All right, take your highlighter, highlight the manganese, highlight the manganese, highlight the bromine, and the bromine. So you can see manganese goes down in charge, so that's our reduction half reaction. And bromine goes from -1 to positive 5, so that goes up, and so that's our oxidation half reaction. So Br minus, arrow goes to BrO3 minus. Skip some lines, reduction half reaction. MnO4 minus, arrow MnO2. First step, balance everything that's not hydrogen or oxygen. That's done for us. Balance the oxygens with water, so 3 HOHs. 2, and we need 2 more over here. Balance the hydrogens with H+. There's 6 here, so I'm going to need 6 H pluses over here. There's 4 here, so I think I need 4 H pluses here. Now balance the charges with electrons. -1 here, +5 here. So that means I'll need 6 electrons here to get this to be -1, so this is -1. Over here I've got +3, and over here I have 0, so that means I'm going to need 3 moles of electrons here. Notice this time, highlight these guys, this is 3 electrons and this is 6. And I've got to get the electrons multiplied so they match, so they equal each other. And so this time I'm going to have to take this half reaction and multiply it by 2. So distribute the 2 and multiply it by each item because I want to get the number of electrons to match in both half reactions. So rewriting this half reaction then would be 2 times 4 is 8 plus 2 plus 6 electrons, 2 MnO2 and 4 HOH. Did I make any mistakes? I think I'm close. Now, box the number of moles of electrons transferred and turn to your neighbor and tell them how many moles of electrons were transferred in this reaction. Now that you got the electrons equal, you can add both equations together. So the left side and the left side here go together. I'm going to try to write it all together here without making too many mistakes. Alright, I think I got most of that copied down correctly. Now we can cancel some things. The electrons go, 3 of the waters go, and we end up with 1 water left. 6 hydrogens go, and we'll end up with 2 hydrogens left. I think everything else stays. And before I go and rewrite it, I now have to deal with the issue that it's in basic solution. In basic solution, there's not hydrogen ions, but there are hydroxides. So I need to add 2 hydroxide ions to both sides. What I do to one side of the reaction, I have to do to the other. And this will cause the H plus then over here to become 2 waters. And these OHs will just be here. This also causes me to cancel another water because there's 1 water right here, and so I'll end up with 1 water on this side. And then when I'm done, I'm going to end up with the overall reaction being the Br minus plus the 1 water plus the 2 of these, and then I've got 1 of these bros over here, 2 hydroxides now, see how those are there, and then I've got a 2MnO2 over here on the right hand side. And I think that's my balanced reaction. Let's check. And -3 total here. 2 plus 1 is -3 over here. The H's, those match. 2 manganeses, 2 manganeses, 1 bromine, 1 bromine. The oxygens, 1 plus 8 is 9. 3, 5, and 4 is 9. Balanced redox reaction. Good luck with your balancing redox reactions.